Scholars, quick review of property of exponents. Of course, the product rule. With the same base, when we multiply, we add the exponents. This is why x to the third times x to the 7 equals x to the 10. X times x, that's y x to the 1, x to the 1, it will be x squared. Same thing with fraction, x to the 1/2 times x to the 2/3. We add the fraction, the exponents, LCD, least common denominator, that will give me x to the 6. So if I were to do the following, the third root of x times the fifth root of x squared, this is the same thing that x to the 1/3 times x to the 2/5. So we just have to add the exponents, just like we did here. Okay. So the power rule, base to the m, then raise another power, we multiply the exponents. This is why x to the square to the third, 2 times 3 will be 6, x to the 6, x to the 2/3 raised to the 4/5. Of course, we multiply exponents. 2 times 4 is 8, 3 times 5, 50, it'll be x to the 1/5. This is why if we have the square root of x and the cube root, this will be the x to the 1/2 raised to the 1/3, which is x to the 1/6. That's the power rule. Product to power, or sometimes we call it the distributive property. A times b to the m is a to the m, b to the m. This is where we have x squared, y3 raised to the 4. 2 times 4 is 8, 3 times 4 will be 12. Quotient rule is an extension of the power rule. On a division, same base, we subtract exponents. This is why x to the 5th divided by x cubed will be x squared. This is why x cubed divided by x to the 5th is x to the negative 2. 5 minus 3 is 2. 3 minus 5 is negative 2. Quotient to power. Again, we can distribute the exponent. If I have a, b to the m, this is a to the m over b to the m. I don't know why I'm using that. If I have a squared b to the 3, and all of that is to the 5th, it will be a to the 10, b to the 15. Of course, negative exponents, we don't like negative exponents. So if I have a to the negative n, this is the same thing as 1 over a to the n. We always send the variable to the denominator. So if I have x to the negative 2, this is 1 over x squared. Careful with parentheses. If I have 2x to the negative 3, the 2 is half in the numerator. We simply move the denominator. If I have parentheses, now we have to move everything down. Okay. And anything to the 0, as long as it's not 0, it's equals to 1. So a to the 0 is always 1. Okay, so that was a very brief recall or summary of exponents, the laws of exponents. Thank you. In the previous video, I left a problem halfway. We can also use this property, a over b to the negative n is the same thing as b to the a, b over a to the n. That's easy. If I have a, b, the negative n, as per the distributive power quotient to power rule, this is the same thing as a to the negative n over b to negative n. We can distribute the exponent to each of the quotient here. But of course, we don't like negative exponents, so we can move this guy to the bottom. And the same reason, if the exponent is negative in the denominator, we can always move it to the numerator. And of course, this is the same thing as b to the a to the n. Same exponent, we can always quote unquote pull it out. Yeah. So that's that rule.